Imagine looking at Earth from space and seeing no blue at all. No Atlantic, no Pacific, no waves, reefs, or floating ice. Just a planet covered in continents, trenches, salt plains, and enormous empty basins. This is the scenario. Every ocean on Earth disappears instantly. The water is gone, along with the dissolved salts and material suspended in it. The atmosphere, land, sunlight, gravity, and the planet's rotation stay the same. This is not the oceans evaporating into the sky. There is nowhere for the water to go. It simply vanishes. The first effect would be physical and almost impossible to comprehend. The oceans contain about 1.3 billion cubic kilometers of water. They cover roughly 71% of Earth's surface with an average depth of nearly 3.7 kilometers. Remove all of that and the seafloor becomes exposed. The ocean basins would not turn into flat, dry floors. They would reveal mountain ranges, volcanic ridges, deep trenches, plains, and sediment thousands of meters thick. The mid-ocean ridge, a continuous underwater mountain chain stretching for about 65,000 kilometers, would become one of the most obvious features on the planet. The Mariana Trench would no longer be underwater, but it would still plunge almost 11 kilometers below the old sea level. That is deeper than Mount Everest is tall. For people living near coasts, the shoreline would race away toward the horizon. Cities like New York, Shanghai, Mumbai, and London would suddenly be hundreds of kilometers from the nearest ocean. Ports would become useless overnight. Ships would drop onto the exposed seafloor, and the world's shipping network would end instantly. But the water disappearing does not mean the climate becomes dry everywhere at the same moment. The atmosphere would initially still contain its normal amount of water vapor. That moisture would begin falling as rain and snow, while evaporation from the missing oceans would fall to zero. So the first few days might bring massive, strange precipitation in some regions. Clouds would still move across the sky, but they would be spending a water supply that can no longer be replenished. Once that moisture rains out, the global water cycle would begin shutting down. Rivers would shrink and stop. Most lakes would drain into newly exposed lowlands or evaporate. Groundwater would slowly seep downward into the empty ocean basins, although much of it would remain trapped underground. Snow and ice would still melt in warm seasons, but there would be far less new snowfall to replace them. The result would be a planet with almost no working freshwater cycle. The remaining water would be concentrated in glaciers, ice sheets, underground aquifers, rivers, lakes, and scattered wetlands. Those reserves might sound enormous, but compared with the oceans, they are tiny. Then the climate would begin to change violently. The ocean is not just a large puddle. It is Earth's main heat storage system. Water absorbs enormous amounts of energy and moves that heat around the planet through currents. Without it, the moderating effect disappears. Coastal regions would lose their mild temperatures. Areas that once had cool summers and warm winters would begin experiencing much sharper extremes. Days could become brutally hot under direct sunlight, while nights could become dangerously cold as the land radiates heat into space. The difference between day and night would grow especially severe across the exposed ocean basins. Dry ground heats quickly and cools quickly. Without water vapor and clouds to trap heat, the surface could swing from desert-like afternoons to freezing nights. Global average temperature is harder to predict precisely because several effects would compete. Removing oceans eliminates their heat storage, but it also removes dark water surfaces that absorb sunlight. Vast new landscapes could reflect more sunlight, especially if covered in salt, dust, or ice. The planet might eventually become cooler overall, while also becoming far more hostile, with much larger regional temperature swings. The exposed seafloor would not remain clean and dry. As the last water evaporated from sediments and underground deposits, salts would crystallize across the former ocean floor. Huge salt deserts would form, some covering areas larger than entire countries. Wind would pick up this dust and carry it across continents. Salt particles would damage crops, contaminate freshwater, irritate lungs, and make many areas nearly uninhabitable. Dust storms would become a global feature, not just a problem in existing deserts. The atmosphere would also start losing one of its most important sources of oxygen production. Marine algae and phytoplankton generate a large share of the oxygen produced through photosynthesis. They would disappear immediately. That does not mean humans would suffocate the next morning. The atmosphere already contains roughly 1.2 million billion tons of oxygen, an enormous reservoir. But oxygen production would fall sharply, while fires and decay continued consuming it. Over long timescales, oxygen levels would decline. The more immediate atmospheric problem would be carbon dioxide. The oceans currently absorb and store vast amounts of carbon. With the ocean gone, that active carbon sink disappears. Plants on land would still remove carbon dioxide, but drought, heat, salt, and ecosystem collapse would weaken them. Marine ecosystems would be erased in a single instant. Coral reefs, plankton, fish, whales, shellfish, and countless microscopic organisms would be gone. This would not be a normal extinction event unfolding over centuries. It would be the removal of an entire planetary biosphere at once. The effects would spread onto land. Birds that depend on fish would lose their food. Coastal wetlands would dry out. Animals that rely on rivers and lakes would gather around shrinking water sources, creating intense competition, disease, and mass die-offs. Agriculture would fail in many regions because modern farming depends on predictable rain, rivers, groundwater, and a stable climate. Irrigation systems designed around coastal or river basins would no longer work. Even crops that survived the first drought would face salt carried by dust and increasingly extreme temperatures. Humanity might preserve pockets of civilization around major aquifers, mountain glaciers, and large freshwater lakes. But these would be temporary refuges, not a solution. Without a functioning water cycle, every reservoir would become a countdown. The disappearance of the oceans would also disrupt Earth's geology, although not by instantly stopping plate tectonics. The weight of the oceans currently presses down on the crust. Removing that load would allow the crust to rebound and adjust. Faults could shift, earthquakes could increase, and volcanic systems could respond as pressure changed. Over thousands to millions of years, the planet would settle into a completely different geological state. Rainfall would carve the exposed basins. Wind would move sediment across them. New mineral deposits would form, but the familiar blue planet would be gone. Eventually, life would not necessarily vanish completely. Microbes could survive deep underground. Some organisms could persist around isolated freshwater systems or geothermal environments. But complex ecosystems, forests, and human societies would face an environment with too little water, too much instability, and no ocean to restore the balance. And that is the most important perspective. The oceans can look like empty space on a map, separating one continent from another. In reality, they are Earth's climate engine, heat battery, water reservoir, carbon regulator, oxygen factory, and largest living ecosystem all at once. Remove them and you do not just lose beaches and seafood. You remove the machinery that makes a stable surface world possible. Earth would still be here. The mountains would remain. The atmosphere would remain. The sun would still rise every morning, but the planet would no longer be the blue world we recognize. And for most complex life, it would no longer be a home.